We are discussing about ensemble approach.
This call is now being recorded.
Okay, so we are going to start with that. These are important topics. Kindly listen carefully. It will be surely helpful for your project, your placement, and all those things, right? So in the last class, we were discussing about ensemble approach, okay? And now currently we are discussing about the methods of constructing ensembles. So you know that what is an ensemble? What is an ensemble? It's a learning algorithm composed of set of base learners. So you may have more than one base classifiers, or base learners means base algorithms, okay? So base classifiers, okay? So different models you may have. How will you take the final output? The final output is based on the combination of this base classifiers. So how to combine this result? So there are different methods to construct the ensemble. What are they? Voting, bootstrap resampling, bagging, boosting. In boosting also you have different variations, ADA boosting, stacking, cascading. Like that you have different approaches for constructing this ensemble. So this is what we were discussing in the last class. And also I have told you about this voting method, okay? So for example, if you use some 5 classifiers, out of this 5, 3 classifiers give one result and another 2 classifiers give another result, okay, whichever is maximum, okay? So that is whichever class is mentioned by more classifiers, so that will be taken as the final output, okay? So this is voting. And another way, you can have different combination of rules when you wanted to combine this, okay? And so either you can apply different rules, like you can apply sum or weighted sum or median, minimum, maximum, product, okay? So any function you can use. And also sometimes you can combine this also and then you can use it, okay? So fusion function, that formula has been given. This is very basic formulas. This also we have discussed in the last class. And now we'll see what do you mean by the stacking. Okay. So it uses predictions of multiple models as features to train a new model and use the new model to make prediction on the test data. Are you able to understand? So what is stacking? So here actually you're giving x and some values. Okay. So this you're giving, okay, data. And in level 1, okay, level 1 you are using some set of classifiers. In level 1 you are using some set of classifiers and it gives some output, okay? So that will be taken as the features and that will be fed into another model. So for example, here assume that they have used decision trees, okay? And so here, so output of set of classifiers will be given as the input to another classifier, and based on that the result will be displayed. Got it? So it is called stacking. So output of one classifier will be given as input to another classifier. Okay. So this we call it as stacking. And different approaches I have told you know, that is, for example, see this, okay, single, this is example for bagging and boosting. So instead of training different models on same data, train same model multiple times on different data sets and combine these different models, okay? Normally assume that this is your training set, okay? So assume that this is the data. So normally what will you give to the model? You will feed all the data, okay? So to the model, that means that to the classifier, what will you do? You will just feed all the data, okay, all the training data. So you will split this data into training and testing, and you will train the model with the entire set of data. Instead, what you can do is, okay, you train the same model multiple times on different data set, okay, then you combine the result. So we can use some simple weak model as the base model, And how do we get multiple training data set? In practice, we only have one data set at the training time. So in that case, what you can do is you can take random sampling with replacement. Okay. So in that case, you can take random sampling with replacement. And what is this boosting us? Random sampling with replacement over weighted data. So here actually what you're doing is you're not going to take the entire data, some random samples you're going to take. And so for example, okay, assume that you have some set of data, okay, and so some random data you just take and just feed it to the model. This is sample one. Take another set of data, feed it into the model, train it again, like that. Okay, so you're going to take random samples and then you're going to feed it. And in case of boosting, for some data you're going to give more weightage. Okay, for some set of data you're going to give more weightage. That is your boosting. Okay, you're going to boosting, you are going to boost some data. That means you're going to give more weightage to some set of data and then you're going to train. Okay. So what is bagging actually? It is bagging stands for bootstrap aggregation. Okay. So what is bagging? Bagging stands for bootstrap aggregation. So as I have told you, this is your entire population. Okay. So here that we represent that as a superpopulation. So from this randomly you pick a sample population 1, sample population 2 and sample population 3. Okay. So you are taking some random population, okay, and then you are going to train the model. So for example, when you consider an analogy, okay, diagnosis based on multiple doctors majority vote. See for example, you are going for a treatment or diagnosis. So one doctor is diagnosing with some disease, okay, so immediately and he is suggesting some surgery or something. Normally, people will not immediately go for surgery. We will take some second opinion. Okay, and if you're not satisfied with that second opinion, again we'll go for third opinion also. And whichever opinion is maximum, okay, that means whichever that is multiple doctors' opinion we will consider, and then we'll take the majority vote. Okay, so majority of the doctors, what they say, accordingly we go for diagnosis. The same way, okay. So here actually, if we have, so when you see here, given a set D of D tuples, this is your entire data, okay. Each iteration I, a trailing set Di of D tuples is sampled with replacement from D, that is bootstrap. And a classifier model Mi is learned for each training set Di. And then classification. So whenever classify an unknown sample X, so what you will do, each classifier Mi returns its class prediction and the backed classifier M star counts the votes and assign the class with the most votes of X. Okay. So what they are telling, assume that you have some set of data. Okay. Assume that you have some set of data. Okay, so this they call it as D, the entire data set. Okay, now assume that you have some 30,000 records. Okay, assume that you have 30,000 tuples or records. So now what they are going to do, they are going to split this data into three. Okay, so this is your D1. Okay, so here they have mentioned as di. Okay, so we'll say that it is d1. Okay, this is d2 and this is d3. So the data will be splitted. Actually, for easy understanding, I am telling like this, but randomly they will choose the value. Okay, randomly they take the data and this will be fed into one model. Okay, this will be given to the model 1 and this will be given to model 2. Okay, and this data will be given to the same algorithm. So you have three models now. Okay, you have three models now. So but with different data you have trained. Okay, with different data you have trained. And now Whenever a new input x is coming, now you have to classify this x. Okay, so take this example itself. So here we have three types of data. One is circle. Okay, so for simplicity I'll take like this. Okay, circle, then this is not like a square, but you consider that as square, and a triangle. Okay, so we have three sets of data, and now a new example. Okay, so new sample is coming. Okay, a new sample is coming, and you have to calculate, so that is, you have to classify it belongs to which class. Okay, it belongs to which class. Okay, and in that case, what will you do? You will feed this new value into model 1 as well as model 2 as well as model 3. Okay, and model 1 is classifying that as circle, model 2 is classifying that as circle, and model 3 is classifying that as rectangle. Okay, so now what will happen is, this is majority, circle is majority. Okay, so now what is your model, final model says is, okay, so that we represent that as m star. So it takes the aggregate value. Okay, so it takes the aggregate result, and based on the maximum voting, now it says that, okay, that x belongs to class circle. Got it? So this is how it works. So prediction can be applied to the, that is, when you say prediction, okay, so can be applied to the prediction of continuous values by taking the average value of each prediction for a given test tuple. Okay, so you can take the average or mean. Okay, so something you can take. So if it is voting, the majority voting will be considered. I hope you might have understood this. So now we'll see algorithmically or mathematically how it has been represented. So take original data set D, so that's what I have told you, okay, with n training samples. So I have told you, no, so assume that in our example, I said 30,000 training examples. Create m copies. Okay, create m copies, that is di, m is equal to 1 to m. So in the previous example, what I said, this m is equal to 3. That means we have d1, d2 and d3, right? Each dm is generated from d by sampling with replacement, and each dataset dm has the same number of examples as in dataset d. Okay, and so here actually they are taking sampling with replacement. Okay, for example, if you have 30,000 data, okay, randomly you are replacing, you are taking some data and they are replacing with similar data. Okay, and so here actually same number of examples as in D. These data sets are reasonably different from each other, since only 63% of the original examples appear in any of this data set. Okay, and train models H1 to HM using D1 to DM respectively. Then use an average model H is equal to 1 by M. Okay, summation of M is equal to 1 to M HM as the final model. Useful for models with high variance and noisy data. Okay, so here actually this is another way actually what they are doing. For example, okay, assume that in D1 some, and what they are telling us 60% of the data will be original, and the remaining 40% they are replacing with similar data. Okay, sampling with replacement. Okay, so you get a different variety of data. Okay, and then you are training the model, and accuracy often significantly better than a single classifier derived from D. For noise data, not considerably worse, but it is more robust and improved accuracy in prediction. Okay, so this bagging methods, it is proven that it increases the accuracy. Now we'll see what is this boosting. Okay, so if you wanted to learn more in detail, okay, you can note down this link and you can learn. Okay. So, boosting is an ensemble technique that attempts to create a strong classifier from a number of weak classifiers. So, how boosting works is boosting is done by building a model from the training data, then creating a second model that attempts to correct the errors from the first model. Okay, so first what you're doing, you're just creating a base model, then you're trying to correct the errors from the first model, and based on that you're creating the second model. So models are added until the training set is predicted perfectly, or a maximum number of models are added. So the basic idea is, take a weak learning algorithm. Okay, we'll stop here. We'll continue tomorrow. Okay. So there is a network problem. We'll stop here, and it's time also. We can. Okay. So today's class we have discussed about the ensemble learning.